Hello, everybody. Today we're going to be having um, on track two Chris Schafer, and he's a senior security operations engineer at Upstart. And he also happens to mentor me. So he's taught me a lot about DevOps and automation. So today he'll be presenting on Intro to Terraform with Amazon Web Services.
Hello, thank you. Good afternoon, everyone. I'm Chris Schafer. I'm a security engineer, which is a really generic title. And I really end up doing work kind of across the board. One thing that I frequently find myself roped into is whenever we need to move to a new technology to improve the security of our company, I can't keep my fingers out of it, right? Like I always need to jump in. One thing that we've been doing recently is we've been pushing for more and more of our systems to be infrastructure as code. Terraform is one of the biggest providers for infrastructure as code, but what infrastructure as code really means is that you can start treating the creation of your servers. You can start creating the permissions, the roles, all the settings for your environment in code. This has become a lot more and more common because when we have these infrastructure as a service providers like AWS, like Azure, coming into the current age, you get to set up all your infrastructure with APIs. And as soon as developers have an API, they want to switch over to do it a lot more programmatically. So I've shared a repo in track 2, and I've included a couple tools. And what we are going to do is walk through how to start doing Terraform. I'm going to intentionally go kind of slow. I'm going to keep an eye on the chat in track 2. I'm going to try to keep an eye on the Q&A in here. If anybody has questions, we've budgeted for time in the middle. I don't plan to wait till the end to answer everything. So feel free to ask at any point. So we're going to start off talking really high level. We're going to talk about what do you want to do to set up your computer for Terraform? This is now probably the 3rd time that I've set up my computer in a different way for developing in Terraform, and I'm sure that there are folks that probably know an even better way. But right now, what I've figured out is Terraform has version upgrades frequently. This means that you need to be careful and know what version of Terraform you're working with. And you want to make sure that everybody on your team is working with the same version of Terraform in the same repo. I like this tool called ASDF. It's for pretty much any coding language, anything that has a lot of versions. It's a version manager. So what you do is you end up putting tool versions file in your Git repo. And if the people have ASDF installed, it makes sure that whenever they run that command, it uses that version. So for this talk, I'm using Terraform 0.14.7, which was the newest version when I was writing it. And it is not the newest version as of 3 days ago, right? Now there's 0.14.8. No major differences between those, but still good to be aware. The other things is to start understanding how Terraform organizes files. So this is all going to be in a Git repo, and you don't necessarily want to have one giant directory with 500 files that lists your that's all of your infrastructure. You start to lose files. You start using grep to find things rather than being able to identify them yourself. It's a huge pain. Your whole folder ends up looking like looking like node modules. So they have the idea in Terraform that you can start splitting stuff into directories, but as soon as you do, that directory is a module. And we'll get into how we handle modules closer to lesson 5, but it's just important to know that the directory really matters for Terraform. The other thing to know is that when you run the Terraform commands, it takes the whole directory, appends all the .tf files together, and runs that, which means it doesn't really matter if it's in one TF file, that TF file can be named whatever you want. There's a couple conventions that we do follow. We try to have a main.tf, which has the core information. You say, I want to use AWS, right? And so you say providers AWS, and we'll go into that in a second, but you do that in your main.tf. And then Terraform will create a versions.tf. And this is where you start to lock the exact version of that provider you're using. So just like Terraform gets frequent updates, your version providers get frequent updates. For instance, Sumo Logic made major updates in their last few versions. And one day, the code that we had was working. The next day, it stopped working because we didn't lock the version. And you want to be cognizant of that, especially if it's not a repo you touch too often. There's also a file that Terraform will create if you do not have a remote state. We'll get more into remote state later, but while you're using it, unless you've configured a remote state, it's going to create something called terraform.tf state. It's a big JSON blob, and you should definitely get familiar with what's inside of it, but you don't want to edit it unless you really know what you're doing, because this is automatically managed by Terraform, and it's how it keeps track of how your resources map. And if you break it, it will make Terraform go crazy. There's some commands that we want to talk about. There's the Terraform init. When we get into lesson 2, we'll be running this. This is what downloads, like if you say I want to use AWS, this is what goes out and downloads that AWS provider. You have the Terraform plan, which says, if I was to take the current repo and apply it to production, what would change? You have apply, which actually does that. And you have destroy, which says all the resources in this repo, I'm done working with them. I want to blow it all away. And we're going to use this a lot too. Another important thing to understand in Terraform is how it controls resources. So when we say I'm using Terraform on AWS, that doesn't mean that everything in my AWS account is controlled by Terraform. And it also doesn't mean that it's all controlled by one Terraform repo. Terraform only controls the resources that you specifically configure it to. So if I create a Lambda on my own, and then I have my Terraform manage a second Lambda, which we will be doing in this, you will not see Terraform touch that first Lambda. It doesn't know what it is. It's not going to mess with it. Yeah, and then always set up your git ignore. Every time you start a new repo, set up your git ignore. If you do it early, it prevents you from accidentally committing files like maybe your terraform.tf state, or maybe a file that has credentials that you're using locally. Terraforms is pretty short, but when you get into other things like Python, you'll see that GitHub has worked a while, and that's already 138 lines. So always a good resource. So before we start using Terraform, we need something to apply it against. I've created an AWS instance. AWS is free to create, but you have to link a credit card to it. There are some ways to link reloadable credit cards to them, but AWS generally tries to avoid that because AWS doesn't even know how much money they're going to charge you until after you've used the resources, and they don't know, and they want to make sure they get their money. But they also provide a lot of free tier stuff. So one of those things is on Lambda. Lambdas, when they are not executed, just the creation of Lambdas generally doesn't cost you money. And then when we're talking about IAM, which is identity and access management, creation of users, roles. Amazon doesn't charge you for those. So theoretically, everything in this presentation should be free. And I haven't gotten a bill from AWS yet while I was testing it out. So be careful, but it should be safe. So now let's go ahead and get it set up. Whenever we start with Terraform, we go read the docs. So we go to, usually this is easy enough to Google, but you'll end up on registry.terraform.io. They will have their different providers, and they will start to show you what it should look like in your Terraform files. So the required providers is what Terraform normally puts in the versions.tf, but since it cats it all together, it doesn't really matter if that's in versions.tf or if it's in main. And then the AWS provider itself is what you want to be using. When we start to look down here, you always need to authenticate with the provider, and they'll show you how to hard code it, but it's easier to just never get in the habit of doing this. And if you build yourself some patterns to not do it, you won't find yourself making mistakes. So what we're going to do is we're going to dive right into it. I'm going to create a new directory so that I don't cheat by using my existing stuff. So I'll create a talk directory right here, and we're going to start creating stuff in there. So as we mentioned, we need that main.tf. And now I want AWS. So what I'm going to do is I'm going to grab the required providers and that provider and throw it in there. It's good. This is one of the things that's sometimes worth hard coding. The region in AWS, the AWS console, you'll notice has tons of regions, and most resources only live in one region. So if you don't set that, a resource can get spun up and you'll never find it again. Once I do this, I almost always run a Terraform in it just to make sure I didn't screw stuff up. And if I'm right, this should fail. It didn't. So normally a lot of them will fail because they don't have the provider configured correctly. Oh, actually, let me try to check this. I'm starting up a new shell, so we know that I have a clean environment. There we go. So it's set up a .terraform directory. We don't ever need to mess around in that. It has this Terraform lock file. This is what Terraform is doing to make sure that the versions match. We don't need to touch that ever. And it initialized. So let's say we wanted to create a resource. Or we'll get to that in a second. So let's start creating the resource that we would want to do for our Lambda. To do that, we need to understand how Lambda works. So what I recommend is we first create one in the console. I created one earlier, but I'll create one now just to show you how it looks. So you put its name in, you choose Python because you want to be a good person and not write Node. And you want to always expand these settings, not because you want to change them, but because you want to know what's happening. On the execution role, it's going to create a new role. And we kind of want to do that. It chose it by default. And then it gave me the option to set up code signing and VPC. I'm not changing these, but it's good to know they exist. So we hit create. It's going to take a second, but don't worry, it's working. And I created a basic thing with a Lambda function .py. So now we go over to Terraform, and we're going to look at our docs and figure out how we do this. So we have Lambda here, and we want to create a Lambda function. Always good to read the notes up there. We're going to skip straight to the code. So whenever we see this, we'll notice that they create an IAM role. So in Terraform, you have resource means that you're creating something or managing something. You have the name of the thing you're creating or managing, or the like name of the library you're using. So in this case, this is an AWS IAM role. This one down here is a Lambda function. And then you have the name that is that only matters to Terraform to keep track of what that instance of that resource is. So this one they named IAM for Lambda. This one down here they named test Lambda. I don't really want to create more resources than I have to, so I'm going to go and create just the AWS Lambda function first, which is what we have down here. So I'm going to go in my main.tf and I'm just going to paste it right in there. Close this and make this bigger. So I know some things I want to change. I don't want Node.js. I want Python 3.8. And I'll take a glance at the resource. See if we can see Python. Nope. We'll still try it. We'll see if it fails out. We also note that they have a file name here. We don't have a file yet. So I copied theirs, right? Hello from Lambda into a code directory and did lambda function.py. You'll also want to read here and see kind of what they're doing. But what I did is I go ahead and zip that up. I created a file called lambda.zip, and I'm going to copy that into this talk directory. And in here, that is now lambda.zip, and over here, lambda.zip. And let's give it a more fun name. So we'll say my first Terraform Lambda. Now the role, we need to create a role for this. Or do we, right? So we saw that this had it create a new role when it started up. So if we go in here and we go to permissions, we'll see a role name. And from here, we see that it wants an ARN. And you would also find that in the docs. So let's steal that ARN, throw it in there. And this says it has a handler of exports.test. So if we check out the docs on that, which we have to scroll all the way to the bottom, but then they have handler, which has the entry point in the code. What's that set on for this one? The handler is set to lambda function lambda handler, and we need to do that same thing unless we wanted to rename it. So we'll paste that in. And this is setting some environment variables. We can leave that in there. We're not using them. So from there, we will now do Terraform plan. So this is going to say, if I ran it, what's going to change? And it says it will create the Lambda, of course. It has a lot of these things that say known after apply. These are things like last modified. This is the stuff that it will figure out as it's applying it. Like, what is this exact resource on Amazon? Because if you notice, like this my console function, it has this whole function ARN. So it's going to calculate a lot of that stuff after apply. So let's do it. I'm going to say yes. And we get a 403. And of course we get a 403 because we haven't set up our authentication yet. So what I recommend for setting up authentication is and if anybody ever gets access to my box, this is how you absolutely decimate me, is start hunting in all my directories for .env files. I like to create these, and they're short shell scripts to set up my access keys. So I'm gonna try to copy this one in. I'm not gonna show it to you because this is recorded and I don't want Datagram going and spinning up a bunch of resources to rack up a credit card bill on me. But we will now do source.aws tokens. I'll echo out the safe one to make sure that we have this. So the access key ID, we have an access key. We are good to go. And where you set this up in AWS, by the way, is on your user. You go to My Security Credentials and you press Create Access Key. And when you do that, it gives you the secret. So let's do that apply now. And it says it added a resource. So we'll go in here, look at it, and we have my first Terraform Lambda. That's pretty cool. We created something. But why are we using Terraform? It was much quicker for me to create that in the UI. Well, let's say somebody comes in here and messed with it. Right? I did that, deployed it. And now I have a bad Lambda running in production. When I do another Terraform plan, it's going to go out and ask AWS, what's the current state of that code? And it says, that's not the code I have up there. I want to make sure that I'm running my code. So when I do an apply, and I say, yes, I do want to. If we go in here and we give this a refresh, you'll see that it went back to the way it was. So we got a little bit of benefit, but we now had to create the role by hand, and we're linked in. This still isn't that nice. So let's look at creating the role. So when we do that, we go and we look at what the role that it has permissions to. So on this, we have a simple role, and it's attached to this execution policy. It also has trust relationships to say that Lambda can do it. Now, I know that some of that stuff's a little AWS specific, but when we put, it's kind of a separate knowledge group than Terraform. So when we look at it, we can see that I've got my Lambda role here. And I basically stole this from up here. Except I also want to have this execution role here attached. So we'll take this, add it in there. And we need that execution role that gets attached. I'm not sure if this is generic between AWS accounts. Somebody that has more AWS experience might know more, but for this one, we will just hard code that in there. We know that that's our execution role. So now we're creating the Lambda role, but we're still hooked to the old one up here, and we don't want to be. So what we'll do is we reference the resource. So we delete that, and we say AWS IAM role dot my Lambda role, because that's the resource name, dot ARN, because this does want the ARN that comes out. So this should take my existing one, say that it wants to change the role that it's hooked to a new role. So when we do a plan, we'll see the new roles didn't get created. And then this one will get modified, but it doesn't even know what it's modifying to because it needs to create the role first. Let's do an apply and see how it goes. So it created a role. It's modifying the function. And it looks like it applied. So now let's go over here and look at that configuration, see what it took to. So now it's hooked to this new role. You will see that that role name is kind of garbage. And that's because in here, we didn't actually give the role a name. So let's say we did. Another nice thing about this is Terraform knows which things can be changed safely without like what's allowed to be changed. On AWS, the name of the role is not allowed to be changed. So it has to delete the old resource and create a new one. So what it's going to do is it's going to replace this role, destroy and create, and then update the Lambda. So when we do this, we should see it all work. And while that's going, I'll go over here and move into the next folder. But yeah, we saw that it destroyed, created a new one, modified the Lambda, and got it working. So if we refresh this, we now see it's hooked to our Lambda Terraform role. All right. So I ignored Datagram's question about showing secret, but it looks like Davey has a legit one. Does Terraform provide the ability to deploy resources in a provider agnostic way across various clouds? Or you always write for a specific provider and the code isn't easily portable? So Terraform resources are provider specific. But when we get to the last stage of this, we'll be talking about a module. And when we write this for a module, you can make the backend for the module change as long as you write it in a way, as long as you write the provider specific implementations of the module you want. So let me hop into the next one. So in this one, we're going to talk about variables in Terraform. So we managed to get our Lambda ARN up here, abstracted out, but I don't want to hard code this in. What if I'm sharing this code with somebody else and they need to apply it to a different AWS account? That has my account hard coded in it. So we're going to talk about variables. In general, we always throw these things in a variables.tf. Like I said, all the Terraform files get concatenated before it executes. So there's nothing except for organization to do this. But it's always worth it. So to do it, I'm going to do a variable. I'm going to call this execution policy ARN. And you generally want to do a description. So on this, we probably even want to put Lambda execution policy ARN. And then you can put a default, but I wouldn't in this case. And then you usually want to put a type in. So this one, we know it's going to be a string. So now that I've created that, I can reference it over here by deleting this string and saying var.lambda execution policy ARN. And now let's do another apply, see what it's going to change. And we see that it prompted me to add a Lambda execution policy ARN. So let's give that a try. We know that that is here, and we're going to copy that, paste it in. And Terraform took a look and it says that there's nothing that needs to get changed, which is good. But like, let's say I type out that. Now it thinks that it needs to change that policy. Now we don't actually want to do that because that would break things, or it would try to reference a policy that doesn't exist. So I control C out. But now let's say I don't want to provide that manually. There's a couple different ways to do this. So if we look here, they talk about oh, and there's also a nice benefit that that Terraform 14 gives you, which is sensitive variables. So like, let's pretend that we don't want to see that execution policy ARN. Let's say that's kind of a secret. I could go in here and say sensitive is true. Do that. I paste it in. Actually, I need to paste in a bad one. And then it says, we have to change this, but I'm not showing it to you because it's sensitive, but it's not. So I'm going to delete this sensitive bit again. But now we don't want to specify it every time we run the command. We can do it a couple of ways. We can say it via a variable in line. So I could do Terraform apply the variable of lambda execution policy ARN equals that. And you could do a couple other things. One of my favorites for not sensitive ones, but that you do want to leave configurable, is I create something like lambda deets dot auto dot tfvars, and then I can just say lambda execution policy ARN equals that. And now, even if I don't include that, it will get auto loaded as a variable. But if the main reason that Terraform allows variables is not for you to use in the root here, but for you to use in modules. So we talked about this directory being a module. In this case, this directory is the root module because that's where we're running the Terraform commands. But what if we want to run it not in the root module? What if I've now described, and I have, how I want to create a Lambda in my account? I can create another folder and I'll call this a Lambda. And I'm going to move my main in there. I'm going to move my variables in there. And then I want to call that. So I'm going to create a new main.tf. And now I want to create one of those lambdas that I defined in there. So what I do is I say module instead. So I say module lambda 1. I have to say where to get it. So it's getting it from lambda, the folder. You can also be referencing some like GitHub repos, and they have some other fancy ways to do it. But when it's local, it's a folder like that. And let's see what happens when we try that. It's going to need me to do another Terraform init. But actually, let me show you what happens if we don't do an init. I'll just do a plan. Terraform's nice enough to say, actually, it's calling out that the module doesn't have an argument. So I do need a Lambda execution policy ARN. So we could hard code it in again. or we could put this variable at the top level. Let's put it at the top level so it's easier to type. So I can actually copy that same variables file. And we have this available again. So here I'm going to do var dot lambda execution policy ARN. So now I do a plan. And it's going to create that in there. But wait, we have the old lambda. What's happening with that? If we scroll up, it's going to destroy it. The reason it's going to destroy it is because this path in the root of AWS IAM role dot my lambda role no longer exists. And because it no longer exists, it's going to delete it. However, this new one that we're trying to create, this module.lambda1, will be created. So what it should be doing is deleting my old one and creating my new one. So, okay, that's okay with us. We'll give that a try. Right, because it doesn't matter how much stuff it's deleting. Oh, but now we've had an issue. It is trying to create the new role with the same name before it deleted the old one. So one of the ways we can handle this, well, in this case, we're going to be able to handle it by just running it again. Because if you notice, after it failed, it went and finished working on all the others and destroyed the old lambda role. But if that didn't work, what we could do is we could say like dash target equals, and we could say the thing that we needed to destroy. So I could have said destroy my lambda role. But it already destroyed it, so we're going to create a new one. And as we saw here, it's gone. It's creating it now. And it's done. But now all we've done is we've moved the code around. That hasn't helped us much. So let's say now what we want to do is we want to spin up two different versions of this. So we want to move some of these things to variables, like the file name. I don't want to have to specify. I don't want to have to always use lambda.zip. So let's do file name. Let's also, so we hop in here, and that is now var.filename. And we also referenced it over here. So we need var.filename. We also want to be able to control the name. So let's just do var.name, and we'll hop back into this variable. But let's say we're kind of okay with the file name being lambda.zip by default, because I don't always want to specify that. But I do want to always have to specify the name. So I've gone and done that. We still have the lambda role down here. And we will hop up now to the top level one, because we need to start specifying some of this stuff. So we have the name. We'll make this my second Terraform Lambda. Let's see what that wants to do. So because I didn't specify a zip file, it's using the default. It's changing the function name, which is required. It has to delete and recreate. And then it should set up. Now, something I actually forgot, but we want to move out also is the lambda role. We're using the same role for all these different lambdas. And we can only have one resource of the same name. So we're going to take that lambda role and we're just going to move it up to the parent for now. And rather than the lambda execution policy ARM, we need the lambda role equals the AWS IAM role, my lambda role dot ARN, and we will hop into here. And this needs to be var dot lambda role, and then we need to make this lambda role. Well, let's say we do a plan. Now here, it wants to delete my role and recreate it. And that's kind of obnoxious. Maybe this is something that actually takes a while. Something you can do in Terraform is you can move things. So Terraform is keeping track of the state, and the state is tied to this path. So I know that this old one and this new one are the same. So let's just move them. So let's say Terraform state move the old one and the new one. All right, let's do a plan now. And now it doesn't need to make a change. So now we've done this, we're calling a module, but let's say I want a second lambda. Rather than having to write all that lambda code again, I can now reuse that same module. So I could say lambda 2. It's still using that same module, the a lambda module. We're still using that same role, but this is going to be, my third Terraform lambda. Now we do a plan, and this is where you have to run Terraform in it. So I'm calling a new module, therefore I always have to do that. It's relatively quick, so not the end of the world. We do a plan, and we're going to get another lambda. So let's apply that. So to Davy's earlier question, he was asking if we had to be specific to the resource. So here's an example of, this is an example of where if I had GCP behind this instead of AWS, as long as I kept the variables that I called the module with the same, I could be changing the module name and it would create it in that provider. This isn't that common in Terraform. As much as people talk about being multi-cloud or migrating between clouds, it's not something a lot of organizations architect themselves well to do. And to be fair, it doesn't always make sense for the organization, but it is possible. So if we refresh over here, we should see our second and third, and we do. And they should be hooked to the same role. So lambda Terraform role, and they have the same code. So through this, we've talked through setting up your environment. We've talked through creating your first resource without any variables. We've talked through tying different resources together with their variables, or with the attributes that they have, like with this AWS IAM role, lambda role ARN. And we've talked through how you build things into a module when you start providing variables back and forth. This is about, I see we're about at the time, right? We have about 10 minutes left. So rather than dive into deeper concepts, what else can I help answer?
Okay, so if anyone has any questions, feel free to type it in the Q&A, or raise your hand and I'll unmute you. But I've got a quick question for you, Chris.
Mhm.
Just out of curiosity, like how long did it take for you to learn all of this, new stuff? And what would you say is the most helpful resource that has kind of taught you a lot of this stuff?
Yeah, so the Terraform docs have been really good. I don't like read them end to end. I read them when I hit errors. I always start at the provider docs. So whatever the first things I was actually working through was managing Cloudflare through this, so that we could manage our DNS and stuff like that at work. And the provider docs are really great. And then as you get more complex, you'll start hitting issues that cause you to dive into more of these language docs, talking about input variables and things like that. And then the second part of the question was, how long did it kind of take me to learn this? I probably only started messing with Terraform in November or December, seriously. And since then, I've only been able to dedicate maybe 10% of my time to it. So earlier in JBest talk, he talked about the Dunning-Kruger curve. I'm probably at that point where I have extreme confidence and I'm not very good at things. But Terraform does lend itself to providing value even before you can become an expert in it.
Awesome, thank you. I think people might be typing in their questions, so we'll give it another second.
Do I think that infrastructure as code is going to play a bigger role in the future? So yes, it's absolutely playing a bigger role. So currently my company is instituting more and more change management. And when we want to do change management, the main things we're trying to make sure is, was every change approved? When we make a change, can we revert that change and go back to the old state? And if something gets modified without permission, how do we find out and go back to the old state? And when we have things like infrastructure as code, all of our software development things, like having pull requests, like the fact that you can revert pull requests so you can go back to previous commits. It makes all of the change management requirements, like the audits, become so easy. The issues that developers have, right? Like somebody breaks something, we're able to fix someone's issue significantly faster by just reverting. And then also when we have secondary, or we have a dev system, we can test out the environment on that dev system and be very confident that the changes that we're making on that dev system will be made the same way on the production one. I have another question here that said, how did I get started learning Terraform? I got started because I made a couple bad firewall changes, and I was really annoyed at myself for not only making them, but screwing up going back from them. So I was mad that even though I knew what I was doing, I made a typo and there wasn't an opportunity for somebody else to catch it. And then when I tried to go fix my typo, I made a second typo. And I really looked around. Cloudflare pushes their own customers to Terraform. They had their getting started post. Half of the stuff in this post doesn't work the same way anymore. They have a nice way to import your existing environment that doesn't really work anymore. But this is really what got me started to start pushing for it at work. And of course, we did it in a number of other places that work. When you look at things like Kubernetes is built on top of infrastructure as code. They try to make everything a YAML file. As I'm sure a lot of people have seen on Twitter, there's a lot of jokes about the YAML file. So that's because everything from how many servers are in the cluster to how it decides when to spin up new servers, to even like what users exist in the cluster, they're all just config files that can live in a Git repository.
Hey Swiss, I got a question for you. Are
Sure.
you a part of the CCDC Black team?
I am.
Do you think that we'll ever see cloud stuff in CCDC?
Yes, though it's always so like we talked about here, where you hook AWS to a credit card and then you hope that you don't charge too much. I know being a longtime member of Black Team, I know that that's always a high concern on our list is how do we provide the students a safe environment when we aren't sure that we have the right funding for whatever they're going to charge. We're always actively looking into it. We're always trying to build more in. I believe during qualifiers, we were starting to use AWS for the jump boxes for teams. And yeah, we're definitely hoping to do more of that in the future. But we are also looking at using Terraform even locally on a Black team. And Wasabi will kill me because he's currently in a fight with me over whether or not we'll do this. But there's a provider for VMware. So even if you're not on the cloud, if I go into VMware here, they have named them all awfully. But they do have their docs for managing even ESX servers. And I don't know which abbreviation is for that. So when we want to, an example of where we would use it is we would create the base team, and then we would say, copy this 8 times, create the resources, and manage it like that. So I got another question here that is, what made me choose Terraform over tools like Ansible, Schafer, Puppet? So Terraform, Ansible, Chef, and Puppet are not, they have overlap, but they have different targets. So Ansible is really for managing the configuration of systems that do not lend themselves to infrastructure as code. So for instance, if I wanted to create an Amazon AMI, if I wanted to create a snapshot, essentially, of a VM that has Nginx set up in a specific way, Terraform would not be very good at that, whereas Ansible, Chef, and Puppet are very good at that. But then once I create that image, I want to say, deploy this image across my infrastructure and stand up the right nodes, and Terraform is very good at that. Ansible is starting to move into that territory because they're an enterprise. They want more customers. Same thing for Chef and Puppet, but it's not, I wouldn't call it their bread and butter. Terraform is more of a competitor with AWS CDK, AWS CloudFormation, and things like that.